Hello, I'm Kuncheng. This is homework 2, problem 2 presentation for course probability and stochastic process. Okay, let's do the problem 2. This one is we have the different signal at the beginning and we have any noisy channel. The signal go through the channel and will change. So we have a probability 0 signal is 0.2 and probability 1 signal is 0.8. And we have some situation is we have a probability the next signal equals 0 where the before 1 is 0, the probability is 0.6. This one is the next signal is 1 signal and the before one is 0, the probability is 0.4. At the same, it's very straightforward. The next one is 0, the before one is 0, the probability is 0.3, and the next one is 1, and the before one is 1, and the probability is 0.7. Also, we know the situation, and the first we need to find the probability. The second signal is 1. What's the probability? And that is easy. We can use the different situation. If we want to find the probability x2 equal 1, and we have to know we have two situations, like we can use like this situation and this situation. The probability, if the first signal is 0, so x1 is 0, and we use this one, the x2 is 1 where x1 is 0, and we have the another situation is if the first one is 1 times, we can use this one, the x2 is 1 and where x1 equal to 0, and we can calculate, plug in the number, and the answer is 0.64. And we go through the second one is we need to know the probability the x3 equal 1. So if we want to get x3, the problem will go up to the twice, like we need to use twice the function. Like it's same as the first one. If you want to get x3 equal 1, so we have to know if the x2 equal to 0. We have two situations. If the x2 equal to 0 and use this function, like x3 equal to 1 where x2 is 0, plus if the x2 equal to 1 times probability x3 equal to 1 where x2 equal to 1. That's the function of the x3. But we don't know we know the probability x2 equal to 1, but we don't know this one. So we have to get this one first, like equal to 0. Like it's almost same as the first question, but we use the this situation and this situation. Like if we have the first one equal to 0 times x2 equal to 0, where x1 equal to 1 to 0, sorry, and plus the probability x1 equal to 1 and times x0 where x1 equal to 1, and we plug in the number is like 0.6 times 0.2 plus 0.8 times 0.3 equal to 0.36, and we know the probability x2 equal to 0, and we know the probability x2 equal to 1, so we can get probability equal to x3 equal to 1 is plugging the number is times 0.4 and 0.64 times 0.8 equal 0.592. Okay, let's do the third one. The third one, we need to find probability x1 equal to 0 when x3 equal to 1. Like if we use the theory of the probability, we can write to this one equal to x3 equal to 1, where x1 equal to 0 times probability x1 equal to 1 and divide probability x3 equal to 1. That's a function come from the theory. But we don't know the probability x3 equal to 1 when x1 equal to 0. So we can use the previous function like for situation. So we get this one. We know the x1 equal to 0, and how to get the probability is we have two situations is when x3 equal to 1 where x2 equal to 0 times because x1 equal to 0, so we need to know the x2 equal to 0 where x1 equal to 0. That's the first situation. Plus the probability is x3 equal to 1 where x2 equal to 1 times probability x2 equal to 1 and where x0 equal to 0. X1 equal to 0, and plug in the number is 0.6 times 0.4 plus 0.7 times 0.4 equal to 0.52, and plug in the number also like equal to 1 equal to 0.252 times 0.2 divide 0.592. The probability x3 equal to 1, you can just plug in the last question, we get the number. Like the final answer is 13/74. And the last one, we need to know the limit when n goes to infinity. We need to know the probability of the xn equal to 0. Infinite. Like this one, we need to use some matrix. Matrix is easier. Like we know the two situation, two probability x infinite equal to 0 probability, and probability x infinite equal to 1. We have two situations. When n is infinite, we only receive the two different signal. One is 0, one is 1. Like we just to get limit n go to infinite, and we write the function is 0.2. That's the x1 equal to 0, and 0.8, that's x1 equal to 1. The two different probability, and we have the matrix is the 4 different situation, and go n square, you can see that the n square, like we can go to get if the n goes to infinite, and we can get the matrix almost equal to like this. This comes from the theory of the matrix. Like we can rewrite the function is we have a probability at beginning, and we have the matrix number, and we can calculate to the another matrix that's equal to this one. This outcome equal to the probability of when n is infinite, the probability of the two situation. So this one we can get when n is infinite and x equal to 0, the probability almost equal to 3/7. That's it. That's the final outcome.